We are going to discuss the gradient of a straight line. First of all, when the word gradient is mentioned, gradient is just the measure of how steep, a line is. Some might say that mathematics is not useful, that it is just a kind of mental disturbance to students. Please, I want you to understand that every topic in mathematics has application. Even your staircases in your house slopes like this, your staircases, it slopes like this, and that is still a line. So engineers also use the knowledge of gradient to determine the nature of the slope or how steep a particular staircase will be in order to make it to be possible for movement to take place accurately. So this gradient is applied in every day of our life. So by the end of the episodes of the videos I'm going to make on this gradient, we shall discuss actually the application of this gradient so that you understand the usefulness of gradient in real life. So keep on checking and make sure you subscribe in my YouTube and Facebook page so that you'll be notified when I will unveil so many series of videos that pertains to gradient. So what am I saying now? That gradient is just the measure of how steep a line is. Look at this line here now, and look at another line. Look at this one, and look at this one. All these things are straight lines. Now, if you try to check, because this is a straight line, and there is what we call the x and y coordinates. Now, if I move from here to here, this distance is in the y direction. Why this distance is in the x direction? You can see y has increased from this particular point to a particular point here. Yx has increased from this particular point to another particular point here. Okay, so I call here x1, here is x2, here is y1, and here is y2. So if you want to get the measure of the change of this y to the x, we are talking about the gradient. That is why they say that the gradient, which is denoted as m, is equal to change in y all over change in x. That change in y over change in x is just the measure of the steep of this particular straight line we've done here. And change in y is y2 minus y1. That is the difference in change. y2 minus y1 over the change in x is x2 minus x1. So this is the formula we use in getting gradient. But the change in with respect to y here to the change in respect to x here compared to this particular one are not the same thing. You can see that the change in y here is too small. Let's assume that the change is 4, for instance. You can see that this change from here to here should be something like 8. Okay, but for here, let's assume that they are equal. Let's say 8 and 8. You can now see that in this case, the gradient becomes 8 divided by 8, which will give us 1. But here, the gradient is 4 divided by 8, which will give us around half. So you can now see that this one is higher than this one. So the more it steeps upwards this way, the more it's approaching 90. And once it approaches 90, it means that there is no change in x. Okay, and once there is no change in x, the graph becomes undefined. For example, look at this straight line here. This straight line, the change is undefined because y changed from this particular point, let's say y1, to this particular point y2. But there is no measure of the change in x. Look at it here. Unlike this one where you can measure the change in x. So if a straight line is like this, it means that the gradient is undefined because change in x is 0. Y change in y can be any value, y2 minus y1. And when you have 0 as the denominator of any fraction, it means that the gradient of that fraction is undefined, because an undefined fraction is a fraction whose denominator is 0. So therefore, even this one also, this is not 0, this is not undefined but 0, because x changed from maybe a particular point to a particular point here, x2. But y did not grow at all. Y is still on this line, it doesn't grow. So change in y in this case is 0 over change in x, which is x2 minus x1. And this will give us 0, unlike this one, which is undefined, infinity. Okay, So you can now see that gradient is just the measure of change in y to change in x. There is a change here, but the change here is little compared to this one. Okay, now there are so many kinds of slopes. If a graph is in this direction, it means it's a positive graph or a positive slope. But when the slope goes towards this way, this is a negative slope. So this is positive, while this one is a negative. These are the things you need to bear in your mind before you be able to get the gradient of a straight line. There are so many cases, or there are so many ways in which the gradient of a straight line can be obtained. Okay, but we are getting to that. But at this particular point in time, I want you to understand that gradient of a straight line is calculated using y2 minus y1 over x2 minus x1. Now, supposing you have 2 points, A, 2, 3, and B, 4, let's say 9, for instance, and you're asked to find the gradient of this particular point. You can actually plot this. You can plot it on the Cartesian plane by drawing your x and y axis. So let's draw the x and y axis very well. Okay. Now, let me assume that this is the origin. Then here is a y-axis. So here is a x-axis. Let's say that here is 2, 4, 6, 8, 10. Here is a -2, -4, -6, etc. So here is 1, 2, 3, 4, -1, -2, -3. Remember, up here is positive for y, down here is negative for y. Left is negative, while the right is positive. Okay, I used two units on the y-axis because the value of y here is up to 9. It's too much. So if I begin to write 1, 2, 3, 4 up to 9, this particular plane may not contain it. Remember, this is the first point, so everything here is 1. The first one is x1, while the second one is y1. The first one here is x2, while the second one is y2. Please take note. So now, when x is 2, y is 3. Look at 2 for x here. Then y is 3. 3 is somewhere in between 2 and 4. So you plot, you mark here. Now, when x is 4, now to plot this, you can see that when x is 2, y is 3. And look at 2 here. You trace, look at 3. 3 is somewhere in between 2 and 4. You mark. Now, when x is 4, y is 9. When x is 4, y is 9. Look at 9, somewhere in between 8 and 10. You mark. Now, having marked, you now join the 2 points you've marked together using your ruler. So now, this is now the line we are talking about. You can actually extend if you like. You can actually increase the line with a ruler carefully. You can see that the line slopes towards this direction. Therefore, it is a positive graph or a positive slope. But assuming it went the other way, it is a negative slope. And to get the gradient, it is very simple. You can actually take any point you like, but don't even stress yourself using the graph to get the gradient. We can use this point to get the gradient immediately. The essence of drawing this graph is to let you know that this is a positive graph since it is sloping towards this direction. Therefore, after getting the slope, our answer must be positive. If we slope this way, after getting the slope, your answer will be negative. Now let us see. Remember, we asked to get the gradient of this point. Gradient m is equal to y2 minus y1 all over x2 minus x1. So gradient will now be y2 is 9 minus y1 is 3 all over x2 is 4 minus x1 is 2. You can actually picture it here. Y2 is 9. Look at that 9 here. Y1, look at the point here. Y1 is 3, as you can see. X2 is 4, while x1 is 2. That is what I'm doing here. So my m will now be 9 minus 3 is 6 all over 4 minus 2 is 2. And when you divide, you are getting 3. Therefore, the gradient is 3, and you can now see that it is positive, no negative value there, to show you that it is a positive graph. Expect more videos on gradient and equation of a straight line. Thank you.